Good morning to everyone, especially to the outside members. This is Norvento Tech and Power speaking. My name is Xabier. And Norvento is already designing and manufacturing and selling medium-sized wind turbines, mainly for the distributed market. This is in the range of 100 kilowatts to 1 megawatt. We have already sold around 50 machines, but our aim is to get the market with sustainable and recyclable wind turbines, and therefore that includes the blades, of course. Let me introduce Claudia from the Blade Engineering Department, who is leading this project in-house, the EOLIAN blade. Claudia?
Hello. Good morning, everyone. Thank you, Xavier. Okay, let me share my screen. Okay, so as Xavier mentioned, Norvento is already manufacturing and designing wind turbine blades in the small, medium size for the distributed energy market. So we design as well the blades. In fact, Norvento main purpose within the EOLIAN project is to design and manufacture two 14-meter prototype blades from different approaches. One of them is going to be a traditional blade, which involves a traditional solution of epoxy and glass fiber composite, and the other one we have a bitumen blade, which involves a composite solution made of natural fibers, in this case basalt, with a combination of the bitumen resin that is being developed throughout the EOLIAN project. It is important to remark that both blades prototypes are going to have the same external geometry, and both of them are going to be validated in terms of design and manufacturing. And the insights that we can get from this validation will help the company and also the partners from the EOLIAN project to understand and to overcome the challenges, understand the benefits that the bitumen resins may introduce to the wind turbine blade manufacturing sector. As mentioned, these designs and these prototypes involve many challenges, some of them, first of all, from the design point of view. Our design team has already taken into account from the very beginning both the material properties for the traditional composite material, the one made from the epoxy and the glass fiber, and the bitumeric composite material, the one made from the bitumen resin and the basalt fibers. And this is because we only account for one mold, which means that both blades will have the same geometry, as I mentioned previously. So the external geometry has to be finely tuned so that the structural efficiency and the load ranges of both blades prototypes stay in similar values. On the other hand, we have the manufacturing challenges, and here the main problems may come from the resin. As you know, wind turbine blades are manufactured via vacuum infusion, and this should be a very controlled process because we need to get repeatability in our manufacturing production processes. You know that there are some parameters for the resin that are already dictated by the wind turbine blade design standards, and there are other that should be very specific and very controlled, such as the viscosity or the process temperatures, in order to get a correct infusion process. So in the very first work packages of this project, Norvento specified in details the materials properties to the people working in the resin and in the composite development, so that they have a guideline to rely on and to focus on. And after that, a little bit of the status of Norvento's work in the project. Well, as previously mentioned, the materials properties were successfully transferred to the partners working on the resin development at the very beginning of the project. we always maintain a frequent communication with them in order to address questions that may arise and also to understand the status of the developments. Then regarding the design of the wind turbine blade, the specifications of the blade were established based in our current 100 kilowatt wind turbine blade. And at the moment, we already have an almost final aerodynamic design, which translates into the external geometry of the blade. And there are still some design iteration happening in the laminates design for the epoxy glass fiber based blade and on the Britimeric blade as well. From 2 months ago, we are also working very close together with our mold manufacturer. And here in the lower part, you can see a picture for the mold that we currently have for a 26 meter blade in the closure process of the mold. And last but not least, why is the EOLIAN project important for Norvento? Well, we are a renewables company and we have always been committed to sustainability and circularity. And as you know, we are aware as well of how difficult it is to separate the materials that are used for wind turbine blade production nowadays. So initiatives such as this, the EOLIAN project, and also the sister projects of which we are going to learn in a few minutes, are very important because they are looking for solutions to overcome this problematic. Additionally, as R&D is a core part of Norvento's DNA, we see the EOLIAN project as a perfect opportunity for combining research, but also for moving a step forwards in sustainability on the wind turbine blades design and the commissioning. And of course, Norvento sees the EOLIAN blade as a potential product for the wind turbine energy sector and also for our customers. This is all from our side, and we will be happy to address questions if any of them arises in the Q&A session.